Okay, Assalamualaikum warahmatullahi wabarakatuh. So the topic today is about rock mass rating (RMR) for rock mass classification. Okay, actually, rock mass rating is one of the method that can be used for geomechanics classification. Okay, basically there are a lot of others method. So now is about RMR. So Rmr was developed by Beniowski at 1976. And if I'm not mistaken, Prof. Beniowski is still alive because I think during 2016 his age is about 77. So maybe currently he is about 81. Okay. So RMR has been applied or have been used in many cases. For example, in tunnel, okay. Okay, for example, in tunnel, chambers, mine, slope, and so on. Okay, why? Because this method is easy to use and versatility in engineering practice. Okay, now we go to the 6 parameters. Okay, for RMR there are 6 parameters. So the first is UCS. Okay, unaxial compressive strength. Okay, what is the strength of the rock material? And then RQD. Okay, for the rock quality. Okay, and then what is the spacing of these continuities? Okay, for example, what is the spacing of joint? And then what is the condition these continuities? For example, joint. And then is it groundwater absence or not? And then the last one is orientation of these continuities. So basically, this RMR can be determined based on table 1. Okay, because why the name is rating? Because you need to give the rating based on the condition when you check on site. Okay, for your information also, basically this manual has been developed by previous lecturer. For example, Dr. Firdaus, PM Aziman, and other lecturers. Okay, basically this method was simplified for the users, for student. Okay, because this is actually the manual for geological camp. Okay, because if you go to a trip, okay, all of you will use this manual. But due to COVID-19, so okay, semua tak ada luck lah nak pergi ke Sungai Lembing. Okay, actually this method develop, okay, untuk geological camp Sungai Lembing lah. Okay, kalau kamu baca yang asal mungkin dia tidak dalam bentuk tersusun macam ni lah. Okay, ini telah di compile. So okay, untuk kegunaan student. Okay, to conduct RMR assessment, so this is all the equipment needed. So samalah macam kamu masak, kamu perlukan bahan-bahan untuk masak. Okay, for example, you have to bring measuring tape. Okay, and then okay, ruler. Normally tape lah. Okay, it's easy to measure the distance. And then smidge hammer. Okay, this one is to determine the UCS. Okay, and then the torchlight. Okay, because this manual normally used in this project or in this camp. Okay, because you go to Sungai Lembing tunnel, so the tunnel is dark, so that's why need to bring the headlamp or torch. And then the important thing is the RNR system. Okay, this will be referred to table 1. Okay, how about the procedure? So there are 10 steps. Okay, but actually this one is for your for this project. But basically in the field maybe is about 9. Okay, so the step start with outcrop preparation. Okay, this is the work area. Okay. Okay, to measure the discontinuity, the condition of discontinuity, and then the step 2, you need to determine the UCS and then RQD and so on, okay, because this one is the 6 parameters, okay, six important parameters for RMR, and then the rest is the analysis, okay, based on the data from 6 parameters. Okay, now we start with step 1. So the outcrop preparation. So outcrop is the exposed surface. Okay, exposed surface. Okay, as the previous project, so each group will be given one work area. Okay, because the outcrop will be your work area, so each group will be given a different area. So you need to measure the distance is about 5 meters. Okay, so need to measure all any discontinuities within these 5 meters. So that's why you need to measuring tape. So if you use ruler, pengsan lah nak guna ruler kan. So it's easy to use a tape, measuring tape. Okay, first after you have your work area, okay, and then the step 2 is to determine the UCS. Okay, for UCS, so to determine the UCS, can use the rebound hammer. Okay, meanwhile in this figure, the A, B and C is the location where you conduct the test. Okay, because each location will give, okay, you need to use different graph. Okay, this one is for position C, this one is position A, this one is position B. Okay, because there is some correction graph, so based on location. So this is the example. Okay, this is the example that rebound hammer available in our lab. Okay, this one is the application in the concrete lah. So in our lab, this is the type. Okay, this is the same brand in our lab. Okay, so basically this is the, I don't want to show you this one because this is for concrete. So how to take the reading is simple. Okay, that is the method. So now you can get the first reading. Okay, so this is reading 1. So for 1 point, normally you need to take about a few points, maybe 10 points. Okay, and then you will get the average of the hammer rebound. Okay, this is the hammer rebound number. Okay, this one. Then you need to do the correction based on the position. Okay, in the video I show you before. Okay, actually that one is for position B. Okay, however when you go to tunnel, okay, however when in tunnel, okay, there is a different condition. So I just show you
situations. The rebound hammer is the only viable alternative to estimate the compressive strength of the concrete.
So this is like this.
There are many other applications.
So based on that video, meaning that when you go to the tunnel, you will use the position A. Okay, that's why later then you need to use the correction line for position A. And then how to get the UCS? So for example, if the number of rebound hammer, the average of rebound hammer is about 30, so you just drag this line to the position A. Okay, because in the tunnel this is position A. Okay, normally in the tunnel. Okay, because you will conduct the testing from the side. So then you will get, for example, this is about 24 Newton per mm. Okay, 24 Newton per mm meter cube. And then you need to put this value in JCS. Okay, this is joint compressive strength. Okay, joint compressive strength. And then so you can put SR. So for unit weight, okay, basically you need to take some sample, bring to the lab, because unit weight is about mass over volume. Okay, and then you will get the JCS, okay, joint compressive strength in MPa. So let's say after you got some numbers, so basically you need to give rating based on table 1. Okay, this is table 1 because this is the first parameters. Okay, shear strength, intact rock material. Okay, so as you can see, there are two methods: point load strength test. Okay, this one is if you still remember, this is lab 3, and then this one is the UCS. So you need to refer to this one. So for example, okay, there is some example. Okay, let's say okay, this one is because they are doing some coring. Okay, and then they conduct point load test, so they will get 8 MPa. So based on 8 MPa, so you just give the rating is 7. Okay, because the example is sorry, not 7. There is sorry, here. So the rating is 12. Okay, because your point load strength test is 8 MPa, so that's why your rating will be 12. Go. Okay, let's say you got UCS 50 MPa, so your rating will be 7. Okay, then we go to the step 3. So this is second parameter is about RQD. So you have learned in the previous chapter that normally RQD is come from the core drilling process. However, let's say, okay, because for example, during the previous camp of Sungai Lembing, so we don't conduct the core drilling because to preserve, okay, the original outcrop of the Sungai Lembing tunnel. Okay, kita tak nak rosakkan dekat Sungai Lembing tu lah. Okay, so if there is no core available, so can use this formula. Okay, the equation of 2. So in question 2, so need to calculate the JV. So JV is the average of the spacing, because normally in one work area it must have a lot of spacing, so need to get the average of the spacing. So then finally you can calculate the RQD. So same also in the step 2. Okay, based on the RQD value, need to refer table 1 to give the rating. Okay, because RQD normally represent the quality of the rock itself. So the higher RQD means that the higher rating. Okay, because this is represent the good quality of rock. So meanwhile, the lower value of RQD, so the smaller number of rating. So let's say in this case, the example RQD value is about 70%. So just refer to the table 1. So 70% is here. That's why the rating is 13. So you just put the, okay, this is first parameter, this is second parameter, so the rating is 13. Okay, in this figure is the example if the coring has been conducted. However, as I told you in previous camp, so there is no coring have been conducted because to preserve the Sungai Lembing tunnel. Okay. Now go to the step 4. So this is the parameters number 3. So this is the spacing of discontinuities. So in the previous slide, I also have been talk about scan line or there is another method also, circular mapping window, but scanline is most method that have been used for measuring discontinuities, okay, because it's easy, okay. And then how to get the spacing of the discontinuities? So just refer to this figure. No, where is the figure? Okay, here, okay. For example, this is the discontinuity number 1. For example, this is joint number 1 or this is joint number 2. So you just measure the spacing. Okay, basically you need to measure the average spacing of discontinuities along the scan line. So in this example, the space is about 300 mm. Okay, it's about 300 mm, for example. So that's why you just go to the table 1. Okay, go to the third. Okay, spacing discontinuities. So 300. So 300 is here. So the rating is 10. Is it correct? Okay, correct. Okay. The rating number is 10 because the spacing, average of spacing is about 300 mm. Okay. So for spacing of discontinuities, you need to get the average. Okay, now we move to step 5, the condition of discontinuities. So for condition discontinuities, there are a few the term that you need to check. So in terms of persistence, aperture, roughness, infilling, and weathering. Okay, so for condition of discontinuities, okay, so now we just refer to the table 1. Okay, must be referred table 1. So table 1 is the crucial table for RMR method. Okay, I will enlarge this. Okay, as you can see, for condition of discontinuities, CE. So what you need to do is refer to E section. Okay, because here you can see persistent, aperture, roughness, infilling, and weathering rating. Okay, so what is the persistent? Persistent is discontinuity of length. Okay. Okay, this is the example of the persistent. So you just measure what is the length of a single joint. Okay. Let's say, okay, this one is vertical, this one is the horizontal. So you just measure the length of the persistence. So you need to check for each parameter for discontinuities condition. Okay, so for example, infilling, infilling, you just use your hand, okay, to touch. Okay, what is the filling in this joint? So let's say this is soft filling, okay, less than, okay, this is the aperture, okay, the aperture of the soft filling. So you just give rating 2. Okay, so for silicon sided, okay, what is the meaning of silicon sided? Okay, because this is the roughness, okay, roughness rating. So roughness, okay, for the roughness, you also use your hand to touch each joint, and then need to give classification. So basically, this method is depend on the what we call, okay, will depend on the person. So you just give, so you just touch the condition and then give the general rating. Okay, and then silicon sided. Okay, what is the meaning silicon sided for roughness? So actually silicon sided is like this. Okay, this is what we call the linear line ataupun jalur lah, in Malay is jalur. So if there are silicon sided, so you just give the rating is 0. So after all the condition for E, for discontinuities has been determined, so need to go back to the parameter number 1, 2, 3, 4. So condition of discontinuities. So you just check what is the previous parameters, each the parameters, and then give the rating based on the parameters. Okay. Now go to the step 6 is groundwater condition. So is it is it dry, is it damp, is it wet, dripping or flowing? Okay, just go to the table 1. Okay, groundwater, you just check. Okay, is it completely dry, okay, damp, okay, what is the condition on the joint? So you just give rating based on condition. So flowing ni teruk lah, dia dah mengalir. Dripping adalah yang menitik. Wet dia nampak macam berair. So damp dia nampak macam ada lembab-lembab, tumpukan lembapan kan. And then this is the good condition, which is completely dry. So the rating is higher. Okay, then go to the step 7, the orientation of discontinuities. Okay, this one need to check about the strike and dip. Okay, so this is the tunnel case. For example, okay, for example, this is the case for a strike is parallel to the direction of driving. Driving is meaning that for the driving here is referred to the, for example, the excavation work. Okay, you start your work here. Okay, meaning that this is the direction of driving. Okay, direction of the excavation work. So now this case is the strike parallel. Okay, selari. Okay, this is strike parallel. Okay, because they are in same condition. Okay, this is the case for strike parallel to the tunnel. Okay, there is another case is strike perpendicular. Okay, because this is your direction of driving, and then right now your strike is here. So as you can see, this is perpendicular with some angle. Okay, because your strike is like this, like this, like this. Okay, and then this is the strike that at 90 degree. So this is driving. So this is your strike. So meaning that this is the 90 degree. Okay, sorry. Okay, this is the 90 degree. Okay, 90 degree. Okay, if you still remember for strike and dip, you need to use right hand rule. So for example, for the first case, strike parallel to the tunnel axis. Okay, this is your drive direction. Okay, this is your drive direction. Okay, first we go to the parallel, strike parallel to the tunnel axis. Okay, if you still remember, you can use the right hand rule. So for example, okay, this one, the dip is here, so that's why your strike is here. So that's why this right now strike is parallel to the tunnel driving. Okay, or tunnel axis. Or if you just turn back, okay, turning your right hand rule. So if the dip here, okay, your strike will be your strike will be here. So still parallel to the tunnel axis. Okay, that's why if you can see, only for perpendicular of to tunnel axis, they will have drive with dip and drive against dips. But for strike parallel to the tunnel axis, there is no drive with dip. Okay, because the dip located at the side. Maksudnya tak ada masalah sebab dia punya cerun ni, okay, berada di sebelah tepi. Okay, berada di sebelah tepi. So there is no problem. Because let's say if you correct, so dia akan fail pada tepi lah, dia tidak mengganggu pada jentera yang mengorek. So and then dip. Okay, and then just give the condition based on the dip angle. So this is dip angle lah. We refer, is it steep or not? Okay, so what is the dip angle here? So it's about 40 to 90. So 20 to 50 is a fair. So less than 20 is also fair. Meanwhile, for strike perpendicular to the tunnel axis, so there are another condition is drive with dip and drive against dip. So dip is slope lah. Okay, this is slope. So when you enter a tunnel, you just check where is the direction of the dip. Okay. So basically this is unfavorable. Okay. So as you can see, there are two columns. So this one is for the first condition, meanwhile this one is for second condition. So if you can see, although drive against dip, okay, there is also two condition of drive against dip. So for this case, okay, because at this case, when the dip when against dip, so the rock can be fall or breaks on the left side. But in this case, when 90 degree, if against the dip, so the slope or dip will be directly fall or fail, okay, onto the driving or the driver. Okay. So this is unfavorable. Sebab slope tu kalau fail, dia akan terus jatuh kepada orang yang correct apabila against the dips. Okay, this one like this. Okay, let's say this is the direction of the slope, okay, ataupun arah slope, and then kamu correct datang daripada sini. So what happen, okay, because this is the direction of the failure, so batu akan directly jatuh. But when drive with dip, okay, when drive with dip, kamu ikut arah dip, so tak apa. If any failure, any fall, dia akan jatuh ke sana. Okay, sebab ni slope dia macam ni, bukannya macam ni. After you have determined the condition of the strike and dip orientation, so for example, for tunnels, okay, give rating based on the condition. Okay, is it fair? Is it unfavorable? Is it favorable? So each condition have their own rating. Okay, so you need to give rating based on the application. Okay, then go to the step 8, number 8. So based on the total rating, okay, you put all the rating value in this table. So finally you will get the total rating value, okay, based on all the parameters. So you will get a number of rating. Okay, after you got a total number of RMR, so then you know what is the grade or what is the class, okay, what is the classification of the rock mass. Is it a good rock, okay, a strong rock, okay, a fair rock, a poor rock, a very poor rock. Because this one will be used for guideline for excavation and tunnel support. Okay, let's say, okay, right now our case is 59. So meaning that this is the fair rock. So when the fair rock for the excavation, you will need support. Okay, so and then it also needs rock balls and so on. Okay, shotcrete. Okay, basically all this parameter rock balls, shotcrete is to give support or to give protection when do the excavation. Okay, now I will show you one of the video, okay, to give you the idea, okay, how the excavation support. What is the excavation support from the RMR value? Okay, the condition.
Actual tunneling process starts. False tunnel section is excavated and RCC lining is done, and then actual tunnel excavation begins. Actual tunneling starts with portal construction, with size greater than actual tunnel size.
Okay, dia start correct sikit demi sedikit.
Pipe for palling with high pressure cement grouting is done for roof stabilization.
akan runtuh kalau nanti dia correct, okay, for excavation process.
And then, actual face drilling starts with twin boom jumbo drill machines, followed by charging and blasting with explosive drilling. Blasting is carried out from center in small units for a distance of 10 to 15 meters, creating pilot holes. Eventually, the full shape and size of the tunnel is achieved. Now, repetitive tunneling method begins. Geologists and surveyors analyze class of rock after every round of blasting operation and find Q value and Rmr value, with change in rock class.
Ini adalah shotcrete. So
based on this data, drilling and blasting pattern is prepared.
Okay, to give protection. Okay, sebab nanti bila dia nak buat next excavation, so maknanya kawasan ni bagi batu yang lemah. Okay, especially for the Rmr with the lower value or lower rating. So that's why it needs protection. So barulah dia akan buat proses pengeroyokan ke dalam lagi.
Pattern is the heart of successful tunneling. All over blasted surface to settle dust. Next step is mucking. Rock bowl drilling and grouting is done as per rock bowl design given by geologists.
Ini adalah rock bowl. Ini untuk penahan retaining.
Depending on rock class, plates are fixed and bolted and predefined amount of torque is applied. Rock bolts are then tested for load-bearing capacity after 15 days. As per requirement and based on geological evaluation done by geologists earlier, preliminary support structures like wire mesh or lattice girder may be erected, after which final layer of shotcreting is done. The process is then repeated for next round of blasting as per the requirement. Monitoring of critical aspects with instruments such as extensometer, if there are any variations.
So itu adalah proses maksudnya it will depend on the Rmr value. Okay, all the rock bolts, shotcrete, steel set, so as the support requirement, okay, untuk mengelakkan any failure ketika proses pengeroyokan tunnel. Okay, I think that's all for Rmr. So, thank you.